Welcome back. Continuing our discussion of stack buffer overflows, now I'm going to go out to my command line, my terminal, and I'm going to compile this program with GCC, which is the standard compiler for Linux systems. It also is available for Windows and Mac systems. So the command is just GCC, and then we give it the name of our program, our C file. And that was stack buffer overflow.c. And we can give it an output name. If we don't give it a name, it creates a program called a.out, which is probably not what we wanted. So I'm going to go ahead and give it another name. But before I do that, I have to do one other thing. GCC is a very good compiler. It's open source. People from all around the world work on it. It's used to build Linux systems. Linux is the operating system by programmers for programmers. So as you might expect, they want this compiler to be pretty good, and they don't want people having stack buffer overflows. So by default, you're protected from such things if you're using GCC. So we have to turn that off. And the way we turn that off is using this switch. -F, no -stack -protector. And that says, I don't want that protection because I'm trying to learn about stack buffer overflows. And now I can give it -O. I would like my program to be called stack buffer overflow. And that compiles nice and cleanly. I run my program, and I'm going to pass it a string. I'm going to pass it 9 characters, and that succeeds. I'm going to pass it 10 characters, and that still succeeds, even though I'm starting to overwrite other memory a little bit further, and we get a segmentation fault. So now we've caused the program to crash. It took a little bit more than just the 10 characters to cause a crash. We will go into the details of why this is in later videos. So in this video, I just want to show you what these vulnerabilities are, and then we will drill down in later videos and we'll talk about, okay, what does it look like on this platform and how can I defend against it? How can I find these vulnerabilities, etc. So let's go back to our editor and let's talk about another possible vulnerability. And that is a heap buffer overflow. Now, I can allocate memory, such as in the stack buffer overflow example, by declaring a variable. What happens when I declare a variable like this local variable here, that variable lives and dies in the bracket where it was declared. So here, it's created inside these brackets, and when it hits this bracket, it dies. Now, where does it live during its short lifetime? It lives on something called the stack. And we will talk a lot about the stack because the stack is very important in understanding vulnerabilities. Now, if you want to allocate a lot of memory, it's generally considered a bad idea to allocate that memory on the stack. Instead, you want to allocate it on something called the heap. So the heap is this big pile of memory, and you are allowed to allocate memory from the heap to your program. And you get to keep it until you actually free it, which I didn't do in this program, which is kind of a bad thing. But this can show you what it looks like when you use the heap. And the function that you call is called malloc. So here, I'm not calling any other methods. I'm just saying, all right, I'm going to create a buffer called buff. I'm going to use malloc and say, please give me 20 bytes. I can overwrite that memory location if I put more than 19 characters input. So I can overwrite this stir copy function, which can cause problems. So if I wanted to improve my program, I really should be calling free here. Okay, so that is my heap buffer overflow. I can compile it. I don't need to protect myself from stack buffer overflows. So I can go ahead and compile this by saying GCC heap buffer overflow.c. with an output of heap buffer overflow. It compiles, it gives me a few warnings. And now I can run it by saying heap buffer overflow, and I'll go ahead and give it some input. I'll give it some more input. Now, this might not immediately crash as the other one did. It might take a little bit more to crash it. Notice that once again, I've managed to cause my program to crash with an abort, which is different from a segmentation fault. So we're going to go ahead and take a quick break. And when we come back, we will look at some other vulnerabilities.